Can you see that? This is the Ainslie COP17 Quantum Magazine 2002 schematic redrawn using standard circuit symbols in the standard 555 layout. Okay, you can check this with the quote unquote publication of this diagram and tell me whether I've got it transcribed correctly or not. Please. I believe I have. I've separated out the oscillator section from the MOSFET section, and what I'm going to be talking about in this video is just the oscillator section, the 555 timer that produces its output on pin 3 to drive the MOSFET power section. Okay? And as I hope you can see right here, I've gone ahead and built the circuit again, yet again. From here over to the right is nothing. That's from a previous demonstration. Everything to the left of my hand is this circuit right here. Okay, exactly. This is the output, pin 3. This is the ground rail. This is my scope probe. This is the duty cycle control pot. This is the frequency control pot. This is my oscilloscope. This is where the baseline is. Remember, whenever I show a single trace, I always put the baseline right in the middle unless there's some reason not to. Now I'm going to turn the channel on. Notice where the trace invert switch is. Polarity positive up. Can you see that? Are you ready? This circuit produces a very long 96% on high duty cycle at pin 3 and only a 3 or 4% low duty cycle at pin 3. Okay, now what I'm going to do is vary the duty cycle potentiometer. This is a 10-turn potentiometer. And if I can find the right screwdriver, yeah, that's a good one. Okay. Get in there. Okay. So now I'm going to vary the duty cycle pot. Here it is cranked all the way to the shortest duty cycle position. That's pretty impressive for a little 555 timer. Now I'm cranking it towards the longer and longer and longer off times, that is shorter and shorter and shorter on times. Focus. And you hear that clicking sound? That's the stop. That is the maximum off time and the shortest on time that this circuit will produce. And that looks to me like, what do we got there? 1, 2, 3, 4. Let's see what that is. Okay. So that is, there's 1, 2, 3, 4 and a half full divisions per period. And so that's a little bit over 25% or 25% duty cycle. 25% off, 75% on. That's the shortest on time that this circuit will produce. Shortest on percentage. Now I'm going to vary the frequency control. Alright. If I can get the screwdriver in the slot. Sorry about the light. Okay. So right now it's cranked all the way over towards the fastest position. Now I'm going to turn it to slower and slower frequencies. As you can see, when I change the frequency, the duty cycle percentage changes a little bit, but not in the right direction. It stays on. Okay, here I've got to change the scope's time base to a slower frequency. Notice that we're still at the highest, or rather the excuse me, the minimum on time, or the maximum, I'm sorry, we're at the minimum on time that this circuit will produce, and this circuit produces an inverted duty cycle from what has been claimed. There is no doubt about it at all. Thank you for watching.